We're going to review limiting reagents and percent yield, determining the limiting reagent in a reaction, and also percent yield. Okay, a limiting reagent is the amount of product formed in a reaction can be determined from the given amount of limiting reagent. And the actual definition, the limiting reagent limits or determines the amount of product that can be formed in a reaction. So we can have a limiting reagent and we can also have an excess, okay? We have limiting and excess. So we're going to be looking at that today. So here we have a sample problem. The properties of a reactant and products differ in the following reaction. Here we have the reaction. We have copper combines with sulfur, gives us copper sulfide, it's a solid. And the question is, what is the limiting reagent when we have 80 grams of copper react with 25 grams of sulfur? Okay, so we have 80 grams of copper, 25 grams of sulfur. So this is what we know, and we have to figure out which one is will we run out of first, the copper or the sulfide, the sulfur. So the first thing we do is find the number of moles of each reactant that is given. So we have 80 grams of copper. We look on the periodic table. 1 mole of copper is equal to 63.5 grams, and we have 80 grams. So it's going to be more than a mole. 80 divided by 63.5, we have 1.26 moles of copper. For sulfur, we have 25 grams of sulfur. And we look on the periodic table. We know 1 mole of sulfur equals 32.1 grams. We get that, the molar mass from the periodic table. So 25 divided by 32, and that's going to be less than 1, be 0.779 moles of sulfur. So we converted, our first step is we converted the grams to moles. Okay, so we're going to be using these two. We're going to be, looking at these two quantities here. So I just rewrote this up here since I have to do it on more than one slide. So the balance equation is used to calculate the number of moles of one reactant needed to react with the given amount of the other. So we have these 2 moles. We just select one. Doesn't matter which one we select. In this example, I selected this particular one, 1.26 moles of copper. So I selected this one. And so we start with our given 1.26 moles of copper. We look on our equation here. For every 2 moles of copper, we need 1 mole of sulfur. Okay, for every 2 moles of copper, we need 1 mole of sulfur. So that would be our mole ratio. Okay, that's our mole ratio. And that's this right here. So we multiply 1.26 times 1 divided by 2. Moles of copper cancel out. And we get 0.630 moles of sulfur. So that tells us for 1.26 moles of copper, we need 0.630 moles of sulfur. That's what we need. And we have 0.779 moles of sulfur. See, that's right up here. We have that. And we only need 0.63. So sulfur is in the excess, okay? Sulfur is in the excess, and copper is the limiting reagent. Okay? For 1.26 moles of copper, we need 0.630, and we have 0.779. So sulfur is the excess, and copper is the limiting reagent. So this would be the limiting reagent. Okay, this is the limiting reagent here. Okay, here we have a practice problem. Determine the limiting reagent. Identify the limiting reagent when we have 13 grams of hydrochloric acid reacts with 16 grams of magnesium. Here's our equation. 1 mole of magnesium combines with 2 moles of hydrochloric acid gives us 1 mole of magnesium chloride plus 1 mole of hydrogen gas. And here I have some hints. First, find the number of moles of each reactant that's given, and then pick one of those. Use the moles of one reactant to calculate the amount of the other reactant that's needed. So you can pause this and do the calculations, and then hit play when you're ready to see the answer. Okay, so we have 13 grams of hydrochloric acid, 16 grams of magnesium. Okay. Just wanted to make sure I kept the numbers the same. First, find the number of moles of each reactant that's given. So we have 16 grams of magnesium. We look up magnesium in the periodic table. It's 24.3 grams. So this gives us 0.658 moles of magnesium. We have 13 grams of hydrochloric acid. We look up hydrogen and chlorine, and it's 36.4 grams of hydrochloric acid. And so we have 0.357 moles of HCl. Okay, so that's the first step. Next step, use the moles of one reactant to calculate the amount of the other reactant that's needed. In this case, I use magnesium. Okay, so here I use this. I pick this one, and I have that here. So 0.658 moles of magnesium times, and here for every 2 moles of hydrochloric acid, we need 1 mole of magnesium. Here's our mole ratio. And so here, we would need 1.316 moles of hydrochloric acid. If we use up 0.658 moles of magnesium, we need 1.316 moles of hydrochloric acid. Okay, this is what we have. However, this is what we need. However, this is what we have. Okay, we only have 0.357 moles of hydrochloric acid. This is what we need. Okay, we'll put need here, and this is what we have. So, it tells us that we don't have enough hydrochloric acid, so therefore the hydrochloric acid is the limiting reagent. Okay, hydrochloric acid is the limiting reagent, and the magnesium is in excess. Okay, the next thing we're going to look at is theoretical yield. This is the maximum amount of product that can be formed from a given amounts of reactants. The actual yield is the amount of product that actually forms when the reaction is carried out in a lab. So you have what you should get and what you get in real life. And the percent yield is that ratio of the actual yield to the theoretical yield expressed as a percent. Okay, so here we have percent is equal to the actual yield over theoretical yield times 100. So in calculating the ratio of the actual yield to the theoretical yield, the percent is a measure of the efficiency of the reaction. The percent yield is usually, less than 100% because the reactions do not always go to completion. So let's take a look at that example we just did. Okay, we just did this one. There's our equation. And it said first find the number of moles of each reactant that's given. That's what we did here. And we determined this was the limiting reagent. Okay, HCl was the limiting reagent. So we're going to use that for our calculations to figure out the theoretical yield. Okay, so use the limiting reagents to find the theoretical yield of, now we're looking for magnesium chloride. Okay, it's a product. Here's magnesium chloride, and that's what we're looking for here. Okay, so we use the limiting reagent to find the theoretical yield of magnesium chloride. So for every 2 moles of hydrochloric acid that's used, 1 mole of magnesium chloride is produced. So we start with our limiting reagent, 0.357 moles of HCl. We found that in the other example. Here's our mole ratio. Let's circle that in red. Okay, mole ratio. And again, we're interested with magnesium chloride and HCl. Okay, so 0.357 times 1 divided by 2 equals 0.1785 moles of magnesium chloride. So if we would have hydrochloric acid and we have this combining with magnesium, we should get 0.1785 moles of magnesium chloride. And so we want to know how many grams that is. Instead of, I did this in 2 steps instead of doing it in 1 step. I could have had this step over here, but I just did it in 2 steps here. We want to convert that to grams, so 0.1785 moles of magnesium chloride. And magnesium, we add up the magnesium, plus 2 times the mass of chlorine, gives us 95.3 is to 1 mole. And so this is how many grams. This is our theoretical yield. Okay, this is our theoretical yield right here. So if we use, in this case, if we use 13 grams of hydrochloric acid, we should get 17 grams of magnesium, 17.01 grams of magnesium chloride. Okay, so that's our theoretical yield. We use the limiting reagent, then look at the equation here, see what product they're asking for, kind of switch the, now they're talking about magnesium chloride. Before we were comparing magnesium and HCl. So we're looking for the theoretical yield, and it should be 17.01 grams magnesium chloride. Now the next question, what is the percent yield? So here we have our equation. We had this. Our limiting reactant was the HCl. We have that many moles. We determined the theoretical yield. This is the theoretical yield here. Okay, that's what we should get. If all of our HCl is used up, we should get 17 grams. However, this is the next part of the question. In our lab, we only produced 13.55 grams. We didn't get 17 grams. We got only 13.55 grams of magnesium chloride. So we're looking at the percent yield. Equals actual yield. This is what we actually got in the lab. Okay, this is the actual yield over the theoretical yield. Here's the theoretical yield times 100. And it turns out to be 79.7%. So of the total 100% product, we only really got 79.7%. The others might have been lost. We might have been maybe the reaction didn't go to completion. Maybe if you transferred beakers, you left some of it behind. Maybe if you were doing a distillation, some of it boiled off, or you didn't boil it long enough, or at the wrong temperature. A whole bunch of things could have happened. So this is the theoretical yield. Okay, so we're given an equation here. A lot of times the first step, we need to find out the limiting reagent, determine how much theoretical product it would produce. Okay, we have for, 2 moles of HCl produces 1 mole of magnesium chloride, and we have 0.357 moles of HCl, so that gave us this many moles of magnesium chloride, and we've converted it to grams. So this is our theoretical yield, but we actually measured out to 13.55. And this would be given to you separate, like the actual yield or, what was produced in the lab. Theoretical yield is you just do the calculations from our equation. Okay, so that's a little bit of a review of limiting reagents and theoretical percent yield. Theoretical yield and percent yield.